we're going to start the test is Chapter 4. Okay, by the way, you should know what tissue is. What comes before tissue? Cells. What comes after tissue? Organs, exactly. Don't lose sight of those basic points. Okay. So and then I don't know if histology, you're doing a little bit of histology probably in lab. Are you guys looking at slides in lab? Okay, you're doing histology. You should know all 4 basic tissue types. C-M-E-N. As in like the sailors, right? Semen. Okay, couple points here. We're going to go over all 4 of these tissues. Now we're not going to go in depth on 2 of them. The reasons for that is because the nervous tissue, that's a whole almost a month in A&P2, and we're not going to worry about that. If you take A&P2, you're going to see nervous tissue in the future. Muscle tissue, later on in the semester, you're going to have muscle tissue. We're just going to know the 3 muscles for now. Later on, it's going to fill out some more. But you do need to know a lot about connective tissue and epithelial tissue. That's where you need to center your center your study on. Epithelial tissue is first. Okay. Key point, know what? We have an apical surface and a basal surface. Basal surface attaches. Apical surface is the free surface. I'm going to go fast through this because I want to get everyone out here in class time. And it's on YouTube, so you can pick it up whatever you don't get. Okay, key point here. Epithelial is avascular. Does not have blood vessels going directly to it. Okay. Know the consequences of that for bone. For skin. The epidermis, what's the consequences of being avascular? Have an understanding of that. 2 is, we look at epithelium in 2 ways. It can be a covering or lining, or it can make up a gland. That's the 2 functions for epithelial tissue. Okay. First, we're going to look at a surface coating. Here, know that there is arrangement and cell shape for epithelial tissues. All this stuff we can describe in 2 ways. Their cell shape and their arrangement. Know all of these. Okay. Know the different ways we arrange them. This is not. Maybe I didn't make this correction. This should be corrected on Blackboard. If it's not, my apologies. I thought I'd corrected this. Stratified is bad for absorption, good for physical or mechanical breakdown. I'm pretty sure I corrected that on the one on Blackboard. But if it's not, I'll make that correction. I apologize for that. Simple epithelium, you can get stuff through it real easily. Stratified, you can't. Know all of those. Know them by description and by visual identification. If you see anything on the test, you will see these pictures on the test. Know how to link those to which ones. So now what we're going to do is look at specific examples of these tissues. Specific examples where we look at them having shape and layer. And we're going to look at the ones with 1 layer first. And I'm going to go through these pretty fast. The first one is simple squamous, 1 layer, very thin cells. Good for getting oxygen from one side to the other. You're going to find this in lungs. Simple cuboidal, nice big cells. Make a lot of hormones in these. You see these in glands. Do a lot of mitosis, or a lot of protein synthesis in them. Really good for that. Simple columnar. These have microvilli on them. You might see the picture and think that looks like hair. Do not think that is like cilia. Those are little finger-like projections. These are really nice for absorbing things. Also, you might want to know what goblet cells are. Those secrete mucus. Going to be a lubricant. Microvilli, know what microvilli are and what they do. They're little finger-like projections that are increasing the surface area. The other one is the cilia one. These have little hairs on them. What you need to know? One, look at the description, see the picture, know what it is. And then two, what's the function of the cilia? Right, know the function of cilia. Pseudostratified. The point with this is one layer thick, but to the histologist it looks like multiple layers. Okay, now what we're going to do is we're now done with the simple. We're doing stratified now. The one stratified that you need to focus your most attention on is the stratified squamous. That's your epithelial. That's your epidermis. Be able to recognize that picture and look at the change. We'll talk about this more when we talk about the integument. But what's happening, how are cells here different than the cells up here? What's the difference? They're more round. Why? Oxygen. They're avascular, but they're getting oxygen from the connective tissue, and the oxygen's going up. But as it goes further away, it gets less. Okay. Transitional, this stuff is going to transition between the shapes. Sometimes it's going to be more cuboidal, and then when you get a lot of, you have a lot of drinks, your bladder fills up and stretches out to a more squamous type of shape. Okay. But these transition between the shapes. You're only going to find these in what place? The bladder. Okay, now we're going to talk about glands. Key thing, what is a gland? You need to know what a gland is. What is a gland? Know that. What do glands do? They release chemicals. Milk, oil, sweat, hormones. Also know what the two types of glands, endocrine and exocrine glands. What are those two glands? Also, what are the differences between an exocrine gland and an endocrine gland? One is how it gets its chemicals out. An exocrine gland is going to take it along a duct. An endocrine gland is going to release it into the bloodstream. When an exocrine releases it along this duct, it goes to the outside surface of the tissue. Endocrine glands are going to release hormones. Our endocrine glands release hormones. LH, FSH, testosterone, whatever you want to say, glands are going to release hormones. In neural tissue, know this diagram and know all the parts to it. If you see that diagram on a test, know how to label that diagram. If you see a diagram on the test, it will be that diagram. I'm not saying we'll see it. I'm just saying if you were to see a diagram where you had to label it, it will be that diagram. I'm not going to pull one off of Google Images to give you. It's that one if you see one. Also know there's two types of nervous tissue. What are the two types? We have neurons, and then we have the neural glial or the glial cells. Those are the support cells. As a matter of fact, that myelin sheath actually is defined as a neural glial cell. So this is showing both neurons and neural glial cells. Okay, and we'll get way more into neurons later. By the way, know what a glial cell is. We're talking about Schwann cells, all these. What I want you to know is glial cells provide support for the nervous system. I think you should at least know that a Schwann cell makes myelin sheath. Know that much at least. That's not too much to worry about. Okay, connective tissue. We talked a lot about connective tissue. Connective tissue, what is it? It's the stuff that holds us together. And the truest definition, it connects us. It binds us together. It's bone. It's blood. Underneath our skin. Part of the dermal layer is connective tissue. Part of the subcutaneous layer is connective tissue. If you take away the connective tissue, you don't got much left. You just got a pile of organs, and then even then it's not much there. Also know it's vascular. Connective tissue is vascular. A couple exceptions, but for the most part it's vascular. We saw this when we looked at bone. Remember all those veins and arteries going into it? Bone is vascular. That's why it's vascular. It has a lot of arteries going into it, veins. By the way, when I say vascular, all I'm saying is that arteries and veins are going into it. Just like we looked at the bone tissue last time and all those arteries going into that bone, that is vascular. When you think vascular, that is vascular. Blood is going directly to it. Know what a fibroblast, chondroblast, and osteoblast is. You see the blast, that should tell you something. This part, not too important about these. It just tells us that there's other cells in connective tissue. And when we looked at skin cells, or the integument system, we saw there's like immune cells in them. This is just talking about that there's other cells in the connective tissue that provide function. Okay, connective tissue. What's the two parts of connective tissue? One part is its cells, and then the second part is an extracellular matrix. So connective tissue can be broken down into cells and extracellular matrix. Okay. So here we go. We have cells and extracellular matrix. For blood, the extracellular matrix is plasma. The cells are red blood cells and white blood cells. Cartilage. Now, one thing here, the extracellular matrix defines the tissue type. The reason blood is fluid is because the ECM is fluid. The reason bone is hard is because that extracellular matrix has become calcified. The reason cartilage is soft is because that extracellular matrix has not become calcified and there's a lot of collagen in it. So the point is the extracellular matrix defines the tissue. If it's soft, firm, liquid, not liquid, whatever, that ECM defines that characteristic. Okay. Matrix is going to vary widely. Sometimes it's liquid, sometimes it's pliable, sometimes it's firm. It changes. Okay, that ECM can be made into two things, ground substance and fibers. Okay, and I use the analogy here. Know this, that if you had to look at ECM, what's the two parts of the extracellular matrix? Ground substance and fibers. Know that. Think of that idea of being rebar in a building. Those fibers give that ground substance something to hold on to. Okay, that's the point here. That it's like rebar and cement. The ground substance is cement. The rebar, those metal lines, are the fibers. Without those metal lines, the ground substance has nothing to hold on to. It won't work. Here, know what collagen is. Collagen is one of those important fibers. Collagen's flexible. This one don't worry about. It's just where collagen is misformed and you get super flexible skin. Nothing to worry about here. Know what elastic fibers are. That's the two fibers I think you should know. Elastic fibers and collagen. Okay, now speaking of this tissue, we talked about tissue. We talked about several examples of connective tissue. All of these, this slide and this slide, are all types of connective tissue. So what we're going to do is we're going to go over some high points through all these tissues. I'm going to go through a lot. But remember, I'm giving specific examples of connective tissue types. Okay, so that's the next 5 minutes. And by the way, for the test, you should know, if I said what are the types of connective tissues, know it's loose connective, dense connective, cartilage, bone, and liquid, like blood and lymph tissue. You should know, if I say what are the types of connective tissues, know the types of connective tissues. Loose connective, we have areolar, adipose, reticular. The ones I want you to focus on here are the areolar and the adipose. We're going to find areolar. Where am I going to find areolar? Skin. Well, not skin, yeah, but under the skin, which is the subcutaneous. There you go. The subcutaneous layer is areolar. Okay, that's what you need to know about the, let's go through some specifics. Areolar tissue, as we just said, it is the basement, so the subcutaneous layer of the skin, the underneath part. Adipose, that's your fat. Lipids, that's adipose tissue. What you need to know, I think we're going with this, adipose does what? Energy storage, and it's an insulator. Reticular, I'm not going to worry about that. Dense connective, what is dense connective? Why is it dense connective? It's dense because there's a lot of fibers. Look at the number of fibers here. Why is this dense? Why is the other one loose? The other one's loose because there's a lot of empty space in between the fibers. Dense has a lot of fibers, not a lot of empty space. That's why it's dense. You have to know tendons and ligaments. You will see that Monday. Know the difference between a tendon and a ligament. And also know where you're going to find dense regular. Dense regular is made of, it makes tendons and ligaments. Okay. Irregular, where are you going to find this? Where are you going to find this? Dense irregular. Excuse me? The dermis. You guys are on it. This is the dermis. So what's above the dermis? Epidermis. Exactly. Exactly. This is going to make the dermis of the skin. Know where to find dense, irregular connective. Also, why is that irregular? Look at all the shapes there. It's not in one straight pattern. That's why it is irregular. Why is it dense? There's not a lot of free space there. Elastic, it stretches. Has those elastic fibers. Those are like those phone cords. They're going to stretch out. If you remember telephone cords, they're going to stretch out, and then they're going to pull back in. Cartilage, just know that I'm more concerned about the hyaline cartilage. No hyaline cartilage, and just cartilage is a connective tissue. What happens when you add minerals to cartilage? Calcifies, you get bone. Also know bone is a connective tissue. We talked about bone. We're just going to say it's connective tissue here. Liquid connective tissue, blood. Blood is a liquid connective tissue. The matrix is plasma, but blood is defined as a connective tissue. Muscle, for now we're just going to learn there's three types of muscle. We have skeletal muscle, we have cardiac muscle, and smooth muscle. Don't think that's all you're going to see in muscle. We got three chapters of muscle coming up. But for now, we're just going to know there's three types of muscle. That's all you need to know for this test. 2 tests from now, you will be so fed up with muscles, you'll cry. You'll say, I never want to see another muscle. Okay, am I going too fast? Okay, integument system. Here we go. Integument system, this is the first organ system we have looked at. What is the integument system? It's your skin and the underneath subcutaneous layer. I expect you to know these 4 functions of the integument system. You should know these 4 functions. Know these 4 functions. What can I say? Now I'm going to talk about each one of these functions in detail. The skin can control temperature. One way is it's going to sweat. That sweat is going to be a heat sink for heat. Okay, if you have an elevated temperature, sweat will sit on the outside of your skin. That heat will transfer to the sweat, which is a liquid, and that liquid evaporates off. And when it does, it takes that energy along with it. When it takes that energy is no longer in you, meaning that you've gone down in temperature. So sweat is going to take heat energy away from you. That's one way you can control temperature. Another way is we have capillaries, and we can determine, or our bodies can direct blood either very close to the skin or very far or somewhat underneath the skin. Now, skin's like a radiator to a car. Right, a radiator does what? Runs fluid through it, and it runs air over that fluid, and then it cools the fluid down, right? Blood's the same way. Blood's going to go very close to the skin when you want to get rid of heat. Because the closer it gets, the more that heat energy is going to escape out. That's why when you run, you become very flushed and red, right? You're doing some physical activity, you become very red. Your face becomes red because the blood's closer to the surface of the skin. Close to the surface, it loses heat energy. You go out in the cold, what happens? You become very pale, or you notice it's changing your skin where it becomes noticeably more pale. In that situation, blood has come further in, and it's not going to the surface. Because it's not going to the surface, your skin changes tone. Because you don't want to lose heat energy in that situation. So the blood's not going near the surface as much. Okay. Basically, that's what I said. The blood vessels in the dermis, closer to the skin when you need to lose heat energy, further in when you don't need to lose heat energy. And we see this in temperature changes. Okay. Blood reservoir. Your skin has about 8 to 10% of your blood in it. You get a severe injury, that's why you turn pale, or that's why you notice a change, because blood's going to be your brain, your heart, tissues, they're going to get preferential say at that blood. You need blood that's going to come from your skin. That's why people turn white when they're cut, because that first place that blood's going to come from is the skin. It's like a bank for the blood. Protection is going to keep bad stuff out. It's going to keep bacteria out. It's going to keep fungus out. Okay. It's also going to keep water out, right? It's going to keep also water in. So it protects us from a lot of bad stuff on the outside, and it also protects us from us drying out. Also, it has pigmentation in it. It has melanin. Melanin is going to absorb UV light. UV light, when it comes to DNA, is bad stuff. It's going to cause mutations. And that melanin in the skin is going to protect us from mutations that can happen from UV light. Makes vitamin D. We make vitamin D in our integument system. Now, we need vitamin D for what? Calcium absorption. You can't, if you don't have vitamin D, I can give you a pound of calcium and you can sit there and shovel it in your mouth. It's not going to do anything for you. You have to have vitamin D. That's why I have vitamin D in milk. You know, fortified with vitamin D. There's a reason. Okay. Also, I like you to know something. How do I say this? I like you to know good walking around sense. And this is kind of an important point, that exposure is going to vary based on race. Not just race, but the amount of melanin in the skin. More melanin in the skin, more UV light absorption, less of it goes to synthesis of vitamin D. And you can search the internet for this, and this can be a problem. Some races have a chronic deficiency of vitamin D because, they're up north, like in Wisconsin or Canada, and there are established, or I should say, well-known deficiencies of vitamin D in certain races, where if they have more melanin, they're not doing this vitamin D synthesis nearly as fast because melanin is absorbing UV light. Okay, but you should at least know that part. Okay, skin layers. Know the layers here. Know the picture. If I was to have this picture without the epidermis and dermis, you should pick up the fact that what's epidermis and what's dermis. Epidermis is avascular. Avascular meaning what? No blood. Exactly. I don't see any blood vessels in there. Nope. Dermis is vascular. What's dermis made of? No. What's dermis made of? Someone loud. You have to give me. I'm an old man. You have to yell. What? It's connective tissue. Yeah, you're okay. A little bit more specific. Dense. Dense what? There's lots of dense. Dense irregular connective tissue. The dermis is made of dense irregular connective tissue. Okay. Okay, also know this idea of what? Mitosis is going on here. It's getting blood supply here, and it pushes up. Right? And the stuff down here is getting the good oxygen, and then as it goes up here, the cells are dying. If you want to see a better picture of that, look at your... What is type of skin? What is this exactly? It's skin. Yeah, well, yeah, a little bit more specific. It's epithelial. Exactly. Getting more specific than that. Is it? No, someone said, is it simple or is it stratified? I see a lot of cells there. It can't be simple. Stratified. What kind of stratified? Squamous. That stratified squamous. Exactly. You guys are on it. Okay, point here. Let's get back to the point. This is what? Stratified squamous epithelial tissue. Now the hypodermis, or I'll say the subcutaneous. That's the stuff underneath. Remember? Does anyone remember what this made this up? Connective tissue. What type? Areolar tissue, exactly. Subcutaneous layer is made of areolar tissue. We talked about skin. You have thick skin, you have thin skin. Know the differences between thick skin and thin skin. Some have glands, some have more glands than the other glands. Know the differences. Same thing here, just know the difference, thick skin and thin skin. Epidermis, that's that top layer. You have the dermis, and then you have the epidermis. That's that top layer. Made of we talked about 4 different cells here. Have an idea of what each of these cells do. We talked about what? Keratinocytes. This is going to make keratin. Keratin is that protein that gives it strength. Melanocytes, that's going to make melanin. What's the function of melanin? It's going to absorb UV light. And remembering back to that last point about synthesis of vitamin D, because melanin is absorbing UV light, it's not being directed toward vitamin D synthesis. Why we see differences based on the amount of melanin in the skin. Okay, so we know what melanin does. Now, dendritic cells, we kind of hit this before. We said that there's lots of different cells embedded in these types of tissues, right? We talked about immune cells and mast cells and stuff. What this says is there's something other, there's some different cells in the epidermis. This is like an early warning cell if there's an infection, that this can start the immune system going if there's a problem, like a cut, abrasion, scratch, whatever. Merkel cell, these are just receptor cells. Okay. We have 15 minutes, and then I'll do the next chapter, and then that will be the review. And if you guys have any questions, you ask, please. Okay. You should know this and this and this. You got that's pretty standard. Know the hormones here. Calcitonin adds calcium and phosphate. Parathyroid pulls it out. Know the hormones there and know which does which. Calcitonin, like adding muscle tone, works out, right? Pumps your body up, all that stuff. That's calcitonin. Parathyroid is going to do the opposite. You know this. This is where our hematopoietic cells are. This is where our red blood cells, white blood cells, platelets are formed, are inside bones. Know the shapes of bones by visual or by verbal description. Talked about long bones. We talked about how are they strong. They have good compressive strength. They have good torsional strength. You can twist them side to side, push up and down, whatever. Good strength. But they don't have a lot of area inside them. Flat bones, that has that spongy bone on the inside, flat bone on the outside, kind of like Whopper candy. That helps out any. High compression strength, low torsional strength. Think of like an eggshell here, right? You can take an egg and break it if you hold it like this. But if you have an eggshell and push down, that's compressional strength. It's really strong. I put an eggshell in my 2 fingers and do this, that's torsional force. It doesn't have a lot of torsional strength. Take a skull and put your hands here and start breaking it, you can feel it giving way. Okay, cube, low flexibility. These tend to break the most. If there's an injury, you're going to see breakage here. Sesamoid. The irregular is kind of like the trash can. If we can't figure out what it is, we just throw it in the irregular bin. Know the different regions of, okay, now we're changing topics. We're talking about the areas on a long bone. The shaft is the diaphyses, then the metaphyses. Here, this is a metaphyses, epiphyses, the area here and there. What's in the center? A medullary cavity, or here it says a marrow cavity. Either term is correct. Also note there is a surface. We're talking about regions, but there's also a surface. See where it's pulling away here? You have the endosteum, the periosteum. The periosteum is that connective tissue layer right there. It's kind of hard to see, but it's pulling it away almost like saran wrap. That's that. Reticular cartilage, you're going to see that on here. That's going to provide movement. That's going to provide low friction. So we talked about bone as being what? What's bone? A connective tissue, right? Going back to this, we talked about cells and ECM. We talked about the cells in bone, and we talked about the extracellular matrix in bone. First part, extracellular matrix. Know what is in the extracellular matrix. What's the ground substance in bone? What is it? No. That's the fibers. No. You're jumping ahead, my man. Fibers. Collagen are the fibers. The ground substance here is a hydroxyapatite. That's that calcium hydroxide, the calcium phosphate. That is the ground substance. Okay. What defines a connective tissue? The extracellular matrix. So what the proportion of ground tissue and fibers here will determine the characteristic of it. I can put bone in some vinegar, some weak acid. I can pull out this mineral stuff here, leaving only the fibers. I can make a bone go from very hard to very mushy and soft. Might even see if we can do that in lab. I don't know. I'd have to ask if we could do that. I'd have to ask the lab coordinator if we have the equipment to do that. But it might be an interesting thing to make the point. I have to ask Ms. Ingram about that. She'd be the one who'd do it. She's the lab coordinator. But anyhow, that would be an interesting little thing. But the point is very simple. Extracellular matrix defines what the tissue is. By the way, what happens when we add mineral salts? We add this in, such as we did today when we looked at the growing long bone. What happens? It gets harder, calcifies. Okay, bone cells. Now we're talking about this part of the house. We're done with this part. Now we're moving on to this side of the house. We talked about 4 types of cells. The take-home here is coming up here eventually. Right here. This is those 4 cells. Now the other stuff has good information in it. I would review it. But if you want a good summary slide, this is good. Don't skip the other slides because I skipped them. I got 6 minutes left, so I'm skipping. But this one, this is the take-home point. Okay. Also, this is the processes that those cells we just talked about are involved in. And I'm going to go through each one of these processes. what I go over with the little pictures in the next 6 or 7 slides is all summarized right here. So I'm going to go through them pretty fast, but if you want to go back to them, this is the summary. First one, that osteogenic cell. It's like a baby pre-osteoblast. I grew up calling it pre-osteoblast. Your book calls it an osteogenic cell. What comes before it? Give it some time, some differentiation, bang, you got an osteoblast. I give that osteoblast some minerals. What's the blast cell? Form something, right? Blast ending. What do I get? I got bone. I let that osteoblast make its bone all day long. I let it encase itself in a shell of bone. What do I get? I get an osteocyte. It's locked in all the bone it's made. Osteoclast, it's going to break down bone. I give it some hormones, in this case parathyroid hormone. Give it some bone, it's going to eat away that bone, and I'm going to get free calcium and phosphate. That little iconoclast is going to do a jailbreak in a sense. He's going to eat away some of that bone tissue around one of these osteocytes, and guess what? It frees him. He frees a bird. He becomes an osteoblast again. And that was all summarized in that one with all the words. Blood supply in bones. Why does bone have blood supply? It's connective tissue, and we know that most connective tissue is very vascular. Now, I've said avascular and vascular. When you see these pictures, this is what I'm referring to as being vascular. This is vascular. This is vascular. See those blood vessels? When I say vascular, that is vascular. Blood's going in, blood's coming out. We know that bone has a very good supply of blood. Oxygen got to go in, waste got to come out. Also, we talked about hormones. What pathway do hormones follow? Bloodstream. What kind of gland do they come from? Endocrine. Exactly. The endocrine glands, which are made up of epithelial. There you go. Those glands are going to release hormone into the blood. We talked about the tissue, the bone being controlled by hormones, right? Well, those glands are going to release hormones. They're going to travel to the bone, and they travel inside the bone by having this vascular system. Okay. Those are the 3 types of arteries. We talked about each one. If you saw the picture, you should have an idea of where they're at. Okay? Also, we talked about veins, right? If you know the arteries, you know the veins. Just take the word artery off and put vein. There you got it. Ossification. We talked about how bone becomes calcified. Entopic calcification, that's something good to know because I think that's good walking around sense. Your arteries become harder, right? You get hardening of the arteries. One part of that is calcification. In this case, entopic calcification. You're getting calcification in places where you don't want it. Everyone heard of an entopic pregnancy? Yes? What is that? A pregnancy outside of where you want it, right? Well, this is ossification outside of a bone. If you think of an entopic pregnancy, same kind of idea. You're getting it outside of the normal place. Okay. We talked about 2 different types of ossification. Let's go through these. Okay, what do I want to tell you about this one? I'm going to come back in a second here. Just know the steps. That's all you need to know about these. Or if you saw this kind of picture, you would see it's intermembrane ossification. Okay. Epichondral, this is the one where you're forming long bones. This are bones in general. This one, it replaces cartilage with bone tissue. You're going to see this in development. I'm trying to think what would be a good testable thing. I haven't written the test for this part yet, so I'm thinking to myself what would be a good testable question. One that you could recognize, if you had this series of pictures, you could recognize that is that type of ossification. And don't lose sight of what we're doing. We're converting cartilage into bone. That's the whole point. We're taking soft tissue and making it into bone. I'll tell you this, if you saw anything on this ossification, it would probably be an extra credit question. I might ask little point things about it, but anything that would come would be from probably an extra credit question, aside from the fact of what is ossification. So probably going to, if you see this on the test, it would probably be an extra credit question. Okay, and that's it. And then we did the material today, and that wraps us up. Any questions? Okay, if you got any questions, you know my office number. I'm here all weekend. Give me a call.